Welcome to the world of C++. Today, we are going to embark on a journey to master the building blocks of one of the most powerful programming languages. Every great programmer starts with a single line of code. Let's look at the classic Hello World snippet that marks the beginning of your journey. The title of our project today is C++ Beginner Project. We will explore the core concepts that form the foundation of software development. Imagine a light bulb turning on. This represents the aha moment when logic and creativity meet to solve complex problems through code. Our first major stop is understanding variables. Think of variables as labeled boxes that store different types of information for your program to use. In C++, we have specific boxes for different data. For instance, an int box is designed specifically to hold whole numbers like 5 or 10. Then there is double, which holds numbers with decimal points, and string, which is used for storing sequences of text like names or sentences. Let's see it in action. We take the number 10 and place it inside our int box. Now, the program remembers this value for later. Next, we need to communicate with our users. This involves two main actions: getting information in and sending information out. When we want to take input from the keyboard, we use syn. It stands for character input and allows the user to type values. To show results back to the user, we use count. This stands for character output, and it prints information onto the computer screen. Observe the flow. Data moves from the user's keystrokes through the code and emerges as a helpful message on the display. Now, let's talk about logic. Programs need to make decisions just like we do. This is where conditional statements come into play. We ask a question, like is the value of x greater than 5? The program evaluates this and chooses which path to follow. If the answer is yes, the program takes one path. If no, it takes another. This if-else logic is the brain of your code. Beyond logic, C++ is excellent at math. It can perform basic arithmetic operations at incredible speeds using simple symbols. Whether you're adding to numbers or calculating complex formulas, these operators allow your program to process data mathematically. We have covered variables, I/O, logic, and math. Now, let's see how they all come together in a complete, functional program. By combining these basics, you can build anything from a simple calculator to complex software. The possibilities are truly endless. It's time for you to take the keyboard. Start your first project today. Experiment with the code, and remember, practice is the key. Happy coding! We can't wait to see what you will create. See you in the next lesson as we dive deeper into programming.
Welcome! Today, we're diving into the world of the to-build a functional, basic calculator from scratch. This project is perfect for beginners looking to master user input and basic arithmetic operations in code. The logic is simple. Where thoughtful numbers, choose an operation. Then let the computer perform the calculation. We'll start by defining our variables. In ditambah 2 usi double to allow for decimal calculations. Next, 2 usi decim command. This is how our program listens and captures the user as input. These numbers are then stored in the system memory, ready for the mathematical operations we define next. Now let us look at the operators. We allow handle addition, subtraction, multiplication, and division. To decide math to perform those as with statement. It is an efficient way to navigate to multiple choices. For addition, we simply add num1 and num2. But this is the most straightforward part of our coding logic. Subtraction and multiplication follow the same pattern, using the minus and asterisk symbols respectively. Division requires extra care. We must ensure the program does because if someone tries to divide the zero, the identity shape. Our calculator becomes robust and professional. To preventing common runtime errors. Finally, we print the result to the console. This gives us the user the answer they were looking for. Let us run the program. That is how the console asks for numbers and can display the sum instantly. To recap, we covered input handling, operation selection, one error checking to build a complete code. Here is the final. Clean ditambah-tambah kode. It is a great foundation for your journey into software development. Keep practicing and experimenting with new features. Happy coding and see you in the next tutorial.
Welcome, aspiring programmers. Today, we embark on an exciting journey into the world of C++. We'll build a functional calculator, a perfect project for beginners to grasp fundamental concepts. This project will demystify core C++ concepts, making them easy to understand and apply. You'll learn about control structures like switch and if-else in a practical, hands-on way. Understanding these structures is crucial for any programming endeavor you undertake in C++. Our calculator will be a solid stepping stone to more complex and advanced applications. So, let's dive in and start coding our very first C++ calculator together. First, let's set up our environment. We begin by including the essential Austrium library. This library allows us to handle input and output operations, like displaying text. Next, we define the main function, the entry point where our program execution begins. Every C++ program needs a main function to tell the computer where to start. Inside main, we'll declare variables to store our numbers and the mathematical operator. We'll use double for numbers to handle decimals and char for the operator symbol. These variables are essential for holding the user's input throughout the program. Now, let's implement the logic for user input. We need to prompt the user for data. Using std::cout, we display a message asking the user to enter their calculation. Then, std::sin reads the input, the first number, the operator, and the second number. This single line efficiently captures all three pieces of information we need. Now, for the brain of our calculator, the switch statement. It allows us to handle different operations based on the operator entered by the user. We'll create a case for addition, subtraction, multiplication, and division. Each case will contain the specific logic for that mathematical operation. Don't forget the default case, which handles any invalid operator input. This ensures our program is robust and user-friendly, even with unexpected inputs. Now, let's fill in the mathematical operations for each case within our switch statement. For addition, we simply add num1 and num2 and store the result. Similarly, we'll implement subtraction, multiplication, and division. But wait, division has a critical edge case, division by 0. We must prevent this to avoid program crash. A nested if statement is our solution. If num2 is not 0, we perform the division as usual. Otherwise, in the else block, we'll display an error message to the user. This makes our calculator robust and handles potential errors gracefully. Finally, after the switch statement, we print the calculated result to the console. This provides the user with the answer to their mathematical expression. Now, let's test our program to ensure everything works as expected. We'll compile and run the code, then input various calculations. Let's try 25 multiplied by 4. The result should be 100. How about 10 divided by 2? That should give us 5. And let's test our error handling. 5 divided by 0. Perfect. Our calculator is working as intended, handling both valid and invalid inputs. You've successfully built a functional C++ calculator from scratch. Review the complete code structure, understanding each part's role. This project has introduced you to fundamental C++ syntax and logic flow. Now, I encourage you to expand on this foundation. Add advanced functions like power, square root, or even trigonometric operations. The possibilities are endless once you master these basic building blocks. Keep practicing, keep coding, and keep exploring the vast world of C++ programming. Thank you for joining this tutorial. Happy coding! Welcome to our comprehensive guide on building a calculator using C++. We'll walk through each step from setup to a fully functional application. First, let's prepare our development environment. A clean ID is essential. We'll create a new C++ source file, typically named main.cpp. Include essential headers like Austrium for input and output operations. This forms the basic structure of our C++ program, ready for our code. Now, let's declare variables to store our numbers. We'll use double for precision. And a char variable to hold the arithmetic operator, like plus or minus. We'll prompt the user to enter the first number using count. Then, we'll read that input into num1 using sin. Next, we ask the user for the desired operation, like plus, asterisk, or, and store it in our op variable, ready for processing. Finally, we'll get the second number from the user. Reading it into num2 completes our input phase for the calculation. The double data type is crucial for handling decimal values accurately in calculations, while char is perfect for storing a single character, like our arithmetic operator. These variables are the foundation for our calculator's core functionality. Now, let's implement the arithmetic operations using a switch case statement. For addition, we'll simply add num1 and num2. Subtraction follows a similar pattern, calculating the difference. Multiplication involves multiplying the two numbers together. For division, we must first consider error handling to prevent issues. A crucial step is checking for division by 0, which would crash our program. If num2 is 0, we'll display an error message and exit. Otherwise, we perform the division and store the result. Finally, a default case handles any invalid operator input. After the calculation, we display the result to the user. This provides clear feedback on the operation performed and its outcome. With our code complete, it's time to compile the program. The compilation process translates our C++ code into an executable file. A success message confirms that our calculator is ready to run. Let's review the complete code, scrolling from top to bottom. Notice the structure, variable declarations, and the switch case logic. This comprehensive view helps reinforce the concepts we've covered. Now, let's see our calculator in action with a sample calculation. It correctly calculates 25 for equals 100, demonstrating its functionality. We've successfully built a C++ calculator. Now it's your turn. Experiment with the code, add new features, and deepen your C++ knowledge. Thank you for watching. Don't forget to like, share, and subscribe for more tutorials. Welcome, aspiring programmers. Today, we embark on an exciting journey to build a functional calculator using the powerful C++ language. Our goal is to create a versatile tool capable of addition, subtraction, multiplication, and division. A fundamental project for any C++ enthusiast. Before we dive into coding, a proper development environment is crucial. This ensures a smooth and efficient programming experience. We'll guide you through setting up or opening your C++ compiler, whether it's GCC or an integrated development environment. A well-configured workspace is your foundation. It's where all your C++ magic will happen, so let's get it right. Every C++ program begins with a basic structure. We'll start with the essential boilerplate code, the skeleton of our calculator. The IOSTRIUM header is vital for input and output operations. It allows our program to communicate with the user. The main function is the entry point of our program. All execution begins here, defining the program's flow. Next, we declare variables to store our numbers and the chosen operator. These will hold the values for our calculations. We'll use std::cout to prompt the user for input, making our program interactive and user-friendly. Then, std::cin will read the user's input, storing it in our declared variables. This is how our calculator gets its data. Now, for the core logic, the switch statement. This powerful construct will handle different operations based on the user's input. Each case within the switch corresponds to a specific operator. For example, case plus will handle addition. Inside each case, we perform the respective arithmetic operation. For addition, it's simply num1 plus num2. Subtraction follows the same pattern. Case handles num1, num2, simple, yet effective. Multiplication is handled by case asterisk, calculating num1 asterisk num2. Our calculator is taking shape. Division, case, requires a crucial safety check, preventing division by 0. This is vital for robust programming. If num2 is 0, we display an error message. Otherwise, we proceed with result equals num1, num2. Finally, the default case catches any invalid operators, informing the user of incorrect input. This makes our program user-friendly. With the logic complete, it's time to compile our code. This translates our human-readable C++ into machine-executable instructions. Once compiled, we execute the program. Watch as our calculator comes to life, ready to perform operations. To enhance user experience, we can add a loop, like do while, allowing multiple calculations without restarting the program. This loop prompts the user if they wish to perform another calculation, making the tool much more convenient. Robust error handling is key. We can refine our code to catch invalid non-numeric input, preventing program crashes. This ensures our calculator remains stable and reliable, even when faced with unexpected user entries. And there you have it, a complete, functional C++ calculator. This project lays a strong foundation for your programming journey. We encourage you to customize and expand upon this. Add more advanced functions like square roots, powers, or even trigonometric operations. You've learned about environment setup, variables, input-output, conditional logic, and error handling. A comprehensive C++ introduction. Keep coding, keep exploring, and keep building. Your C++ adventure has just begun. If you found this tutorial helpful, please like this video and subscribe for more C++ programming guides and projects. Join our community of learners and continue mastering the art of C++ development. Happy coding! Welcome to the future of computing. Today, we delve into the heart of C++ to master conditional logic and decision-making. Have you ever wondered how a program chooses between two paths? It all comes down to the logic of the code. Our mission is simple: understanding the if-else statement and the switch case block. These are the building blocks of intelligent software. Imagine a crossroads where every turn is decided by a condition. If the light is green, we go. If not, we wait. Before we can write a single line of code, we must prepare our digital workshop. Let's set up your development environment. Popular choices like CodeBlocks, Dev C++, and Visual Studio Code are waiting for you. Choose your weapon. Opening the IDE is your first step. Look for the New Project button to begin your journey into the world of logic. Now, the canvas is ready. Every great C++ program begins with a basic structure that the compiler understands. First, we include the input-output stream library. Then, we define the main function where the magic happens. Notice the brackets and semicolons. In C++, precision is key. Every symbol has a specific purpose in our logic. Let's compare our two titans. On the left, the versatile if-else. On the right, the organized switch case statement. If-else is perfect for ranges and complex conditions. Switch is your best friend when dealing with many fixed values. When the logic is sound and the syntax is correct, we compile. Witness the satisfaction of a program that runs perfectly. You've just taken your first step into a larger world. Keep coding, keep testing, and let your logic lead the way. Welcome to the world of C++. Today, we're laying the technical foundation for your journey into one of the most powerful programming languages ever. Before we can build complex systems, we must first understand the environment where our code comes to life. Let's look at our essential tools. First, we have CodeBlocks, a free and open-source IDE built to meet the most demanding needs of its users. It is highly extensible and fully configurable. Next is Dev C++, a classic choice known for its simplicity. It's a full-featured integrated development environment that is perfect for those just starting out. And finally, Visual Studio Code. This modern powerhouse is incredibly versatile, supporting nearly every language with a vast ecosystem of extensions and themes. Now, let's open our editor. Imagine a blank canvas, ready for your logic. We start by creating a new source file with a .cpp extension. A virtual cursor appears at the top left. This is where every great project begins. We must tell the computer which tools we intend to use. We begin with a preprocessor directive. We type the hashtag symbol followed by the word include. This tells the compiler to prepare for something special. Inside angle brackets, we add IOStream. This is the standard input-output stream library, the bridge between your code and the outside world. Next, we add using namespace std. This line is like a shortcut, allowing us to use standard names without repeating the std prefix every time. Let's break down the functions. Within IOStream, count stands for character output. It is the tool we use to print information to the screen. On the other hand, sin is for character input. This allows our program to listen to the user, capturing data from the keyboard for processing. Combined, these elements form the skeleton of your program. See how the structure is clean, logical, and ready for the logic we will soon add. Every complex application, from games to operating systems, relies on these fundamental building blocks. You have successfully taken your first step. Practice this basic setup. Familiarize yourself with the syntax. In our next session, we will dive deeper into variables and logic operations. Happy coding! Welcome to this programming tutorial. Today, we are building the foundation of a C++ calculator, starting with its entry point. To create a functional application, we must understand the structure that the compiler looks for first. Let's start with a blank slate. Our C++ file is ready for the first lines of code. Now we create the main function where the program will run. In main, inside this function, we will write all our calculator logic. Before we code, let's visualize the flow. We need user input, a mathematical operation, and a clear output. We define our variables inside the main block to store the numbers provided by the user. Adding comments is a vital practice. It helps us and others understand the purpose of each section of the calculator. Notice the syntax. Every detail, from the parentheses to the semicolons, ensures the program compiles correctly. With the logic set, we open the terminal. This is where we will see our code come to life. We have successfully defined the entry point and organized our logic flow. The foundation is complete. Great job today! Keep practicing, and remember that every complex application starts with a single main function. Happy coding! Greetings, future architects of the digital age! Are you ready to master the most fundamental skill in programming? Today, we are constructing a simple calculator. But first, we must understand how to talk to our computer. In C++, before we use data, we must announce it. We call this variable declaration. It is the foundation of logic. Think of the computer's memory as a vast, empty warehouse. Without labels, everything would be chaos. When we declare a variable, we are essentially placing a reservation on a specific spot in that memory warehouse. Now, let's look at our first power tool, the double data type. It's built for precision and power. Behold the code. By writing double num1, num2, we tell the computer to prepare for numbers with decimal points. Imagine double as a glass container. It can hold simple integers like 10 or complex decimals like 3.14. These containers are labeled num1 and num2. They are ready to store whatever numerical values our user provides. But a calculator needs more than just numbers. It needs to know what to do. Enter the char data type. By typing char operation, we create a special slot for a single character like a plus, minus, or star. Think of char as a tiny drawer. It's perfect for one symbol that tells our program which math road to take. Now, let's assemble the whole machine. We start with include iOstrium to give our program a voice. Inside the main function, the computer begins its work. It's time to ask the user for input. The terminal pulses as it asks, enter first number, operator, and second number. It's ready for action. But how does the computer decide which math to do? It uses if-else-if logic, the brain of our program. If operation is a plus, we add. If it's a minus, we subtract. Each choice is a separate circuit. Wait, stop the press. We must be careful. Division by 0 is a digital disaster we must avoid. By checking if num2 equals 0, we ensure our program remains stable and smart. Safety first, programmers has success. The calculation is complete. Look at that beautiful result displayed on the screen. You've mastered double, char, and declaration. You are now well on your way to C++ mastery. Keep coding, keep learning, and remember, every great program starts with a single line of declaration. In this final segment, we reach the conclusion of our C++ calculator journey. It is time to seal the code with the proper exit status. Every line in C++ is a precise instruction. Here, we type return 0 followed by a semicolon to conclude the main function block safely. The return 0 statement is more than just a line of code. It is a success signal sent back to the operating system upon completion. When you see the process finish notification in your terminal, it means your program ran perfectly from start to finish without any fatal errors. Now, let us pull back and admire the full architecture. Here is our entire 10-line calculator program. displayed clearly in our dark mode editor. From the headers at the top to the final closing bracket, every element works in harmony to perform mathematical calculations with high precision. At the very top, we included the IOStream library. This is essential for any program that needs to communicate with the user via text. We initialized 3 variables: 2 doubles to store the numbers for calculation, and 1 character variable to store the arithmetic symbol like plus or minus. The input stream, or SIN, is how our program listens. It waits for the user to type their values and stores them securely for processing. The switch statement acts as the brain of our calculator. It evaluates the operator symbol and decides which mathematical branch to execute. Inside the switch, each case handles a specific operation. Whether it is addition or multiplication, the logic is clean and efficient. After the calculation, the count statement takes over, displaying the final result on the screen so the user can see their answer clearly. With everything in place, we hit compile. The code is transformed into a functional application, ready to serve as your personal desktop tool. Coding complete. You have successfully navigated the basics of C++ syntax, variable handling, and control flow. This is a massive first step. Take this code, experiment with it, and try adding new features. Thank you for following along, and happy coding on your next project. Welcome to this C++ tutorial. Today, we are going to build a functional console-based calculator from the ground up. We will focus on basic arithmetic operations and how to use switch statements to handle user decisions efficiently. First, let's look at the interface. A clean digital screen appears, prompting the user to enter operation like plus or minus. When the user types a symbol, the program captures it. We assign this keyboard input to a variable called operation. Now, let's dive into the core logic. We use a switch statement to evaluate which operation the user has chosen. The switch statement acts like a selection mechanism, routing the program to different calculation branches based on the input. If the user enters a plus sign, the program executes the first case. It adds num1 and num2 together instantly. For subtraction, the program simply calculates the difference. The resulting value is then output directly to the console for the user. Multiplication follows the same pattern. The switch logic ensures that only the relevant math code is executed for each request. Division requires extra care. We must include a safety check to ensure we aren't dividing by 0, which would cause an error. If the divisor is 0, the program displays an error message. Otherwise, it shows the correct quotient of the two numbers. What if the user enters something else entirely? We use the default case to handle invalid operators and issue a warning. Finally, we end the program with the return 0 statement. This highlights the successful and clean completion of our C++ process. Let's review the full code. From the include directive at the top to the closing brace, every line plays a role. Congratulations on completing your calculator project. You've learned about input, switch statements, and basic program logic today.